Hi everyone, welcome to the very first lecture of the course. So before we delve a bit deeper into geology, we have to start with the very basics, and we're going to start by having a brief overview of rocks, as this is geology. So if you want to go over the slides yourself, feel free to mute me, go at your own pace, but I will be going into a bit more depth myself, so it might be worth not muting me. So let's start with some basic definitions. These aren't generally that useful, but if you're revising for exams, it will be worth remembering these because they love to ask these kind of questions. So, what is a rock? A rock is a naturally occurring solid aggregate of one or more minerals, and a mineral is a natural solid substance with a fixed atomic structure, a chemical composition that varies within a limited range, and a crystal shape which is controlled by atomic structure and is hence diagnostic of the mineral. Now, moving on to the more general sort of stuff, there are three main types of rock, and that is igneous, sedimentary, and metamorphic. So, igneous rocks are made from cooled molten rock, and they can either be extrusive, which is where they've been exposed to the surface through a volcanic eruption or something like that, or intrusive, where they've cooled and solidified, so turned into rock, underneath the surface. Sedimentary rocks are made up of sediments or clasts that have been eroded from other rocks, transported into one area through like rivers, gravity, etc., and then lithified. Lithified or lithification basically means it's like the process of turning sediment into rock. Metamorphic rocks have been recrystallized through heat and pressure, but they haven't been melted. If they had been melted, then they would then be classified as an igneous rock. Now, if we look at each group in a bit more depth, starting with igneous, why do they form? Well, molten bodies of rock exist beneath the Earth's crust, and this molten rock is much less dense than its surroundings, so naturally it wants to rise up. And it can do this through forcing its way into the above rock through dikes and sills. Dikes and sills are classified as intrusions, and you can see them in the diagram there. So they're called intrusions because they basically intrude into the surrounding rock. They force their way through. Sills kind of go along the bedding, so they're classified as concordant, and dikes force their way up through without any real regard for any structures, so they're classified as discordant. Now, the surface is a lot less hot than the core, so this combined with a decrease in pressure allows the rock to cool and eventually solidify. Molten rock can also cool if the entire body is lifted upwards, such as in a mountain building event. So, igneous rocks can either be classified as mafic, intermediate, or felsic. There are some other names for these terms, like sometimes you'll see mafic being called basic or felsic being called acidic, but these are the main general terms. So mafic rocks are rich in iron and magnesium, but the biggest defining factor, which is what is generally used to separate the classifications, is silica content. So mafic rocks have between 45 and 52% silica. Intermediate rocks have between 52 and 66% silica, and felsic rocks contain over 66% silica. Another thing to note is that if you look at mafic rocks in the field or in your hand specimens, you'll notice they're generally a lot darker than felsic rocks, so that's a good way to tell them apart. So, taking a look at sedimentary rocks again, how do they form? Well, they can be formed through chemical and biological action. We'll look into that in a bit more detail later, but the main mechanism of how they form is exposed rock faces are subject to weathering and then eventually erosion, and these eroded sediments can be transported through gravity, wind, rivers, etc., before accumulating in a lower energy area like the inside of a river meander bend or at the end of a valley where the gradient drops. So these built up sediment deposits are eventually buried where they can then be lithified through diagenesis, so turned into rock through diagenesis. Diagenesis is basically any chemical, physical, or biological change undergone by a sediment after its initial deposition. It turns sediment into rock. It's usually caused by a slight increase in pressure and temperature due to burial, and this relates to the geothermal gradient of the Earth. So the geothermal gradient is the increase in temperature as you go down towards the Earth's core, so an increase in temperature with depth. I'm pretty sure the average is something like 25 degrees Celsius per kilometre, but this varies throughout the world depending on the underlying geology and factors like that. So looking at metamorphic rocks again, what causes metamorphism? So metamorphism is the rearrangement of the crystal lattice, and that occurs either due to heat, pressure, or a mixture of both. Pressure-based metamorphism is often referred to as burial metamorphism. Temperature-based metamorphism is often referred to as contact metamorphism, and this is usually caused by a rock being in close proximity to newly intruded igneous bodies. So that can include the intrusions we mentioned earlier, such as dikes and sills, or also batholiths, which are basically huge bodies of molten rock that have accumulated. Regional metamorphism is a mixture of both heat and pressure. This is the most common, and it forms through a wide variety of tectonic events, but again, we'll look into this in more detail later on. So that is it for the first lesson. I hope you enjoyed it, and I hope it was useful to you. For these kind of initial lessons, I know you're probably thinking, oh my god, that was boring. And I don't blame you for that, but I promise it's worth sticking with things, as geology does get a lot more interesting.